Hello and welcome to SudoKanard. We're here to solve this puzzle that dates back to 2025. This is Arrow Skyscrapers Sudoku, and it was featured in Sudoku Mahabharat, and it was requested by Tyler, who has a lot of difficulties solving this puzzle, and I can definitely understand that. This is pretty confusing. So this uses the rules of arrow Sudoku, where this digit is the sum of all digits along the arrows, and also the rules of skyscrapers, in which those clues tell us how many digits can be seen when considered as the heights of buildings. So the place to start looks to be here. This is the sum of those three digits and this digit. Those three digits sum to at least 6, 1, 2, 3, plus at least 1. So this is at least 7. So this is 7, 8, or 9, which means that 9 will be seen very late in the column. So 9 will be somewhere here, but 9 won't work here because the sum here would be more than 9. And 9 here would force this to be a 1. If I try 9 here, then this is 1, and 1 can never be the sum of those three digits. So that 9 is actually here. So this is the first thing to see. Now, a 9 here would mean that we have 1, 2, 3, 4, 5, 6, 7 here, and 8 there. But 8 there would force this to be a 2. That doesn't even work. And you can see that 8 here doesn't work either, because this would be at least 11. So 8 can't be further than that. And with an 8 here, the maximum value here for the skyscraper clue is already 7. If you put ascending digits here and 8 there, and those two are hidden, this is seen, and we only see 7 digits. So 8 is already, so 7 is already the maximum number of buildings that you can see with putting 8 here. If you try to put 8 lower, then we won't reach 7, and this will be broken. So what comes out of all of this is that 8 can only be here, that this is 7, and that the digits here are ascending, which means that we'll have something like 1, 2, or 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, but 5 is not available, and 6 or 7 there. And so those are ascending, and those are hidden behind the 8, and 9 is seen. And 7 here is actually the minimum value achieved by 1, 2, and 3 in those 3 cells, and 1 there. And with the 1, 2, 3 triple, this is 4, this is 5, this is 6, this is 7. And in this column, those are from 1 to 3. So that is definitely the place to start. And now, where do we move on? It's interesting that this is the sum of those 3 digits. That's a minimum of 4, which would be achieved with 1 here, 1 and 2 there. So this is at least 4, which, and actually we already knew because of this 9, that 9 has to be somewhere in those cells on this row. And those arrows tell us that 9 can never be on those cells. And let's ponder this. As I said, this has a minimum of 4, and this also has a minimum of 4, so that 9 can't be here. And I said this has a minimum of 4, And now, because 9 is here or there, this has a maximum of 6 as well. So those digits can't be too high. But can they be that low? If they are very low, let's say this is 4, in which case we have 1 here, 1 and 2 there, then this arrow clue will have to contain a very high digit. To be more precise, the minimum values here are 3, 4, 1 and 1. And that's the only way for the sum here to be not more than 9. But if you put a 9 here, then the digit here must be a 2, and this breaks. So that 1 and 2 here is not enough. So that can't be a 4 here. And 9 can't be here. 9 has to be there, which tells us that this can't be more than 4. And I said it in the beginning that it had to be at least 4. So 4 is the only value, and it can only be achieved with a 1 here and 1 and 2 there. So we get 3, 4, and 9 in those cells. And because of the 4, those are ascending, which is not saying much at that moment. Here we get 6, 7, 8, 9. That's not interesting at this point. Now let's have a look at this. So we already saw that 1 and 2 here doesn't work. So the minimum value is with 1 and 3. And now because of this one, the minimum value in this cell is 2, which means that the minimum sum for this is 6, so it has to be a 6. And because this is 6, it means that the digits here are ascending, and you can see that 8 here wouldn't work, because now the sum here would be at least 9, which is not available. So that 8, knowing that this is ascending and this is ascending, 8 must be here. So 8 is the sum of those two digits, which will have to be addressed at some point. Okay, perhaps I should... Does 7 work here? 7 would seem to work with 1 here and 8 there. That definitely works. All 7 could be here. Oh, what I'm seeing is that this is at least 6. If this is 7, then this is at least 6. And if 7 is here, knowing that those are ascending, this must be a 7. And by the way, 1 on this row can only be here. And 2 can't be in this part, so 2 will be here. That's a 3. And actually knowing that this is ascending, this is from 3 or 4, 4 or 5, 5 or 6, 6 or 7. Simply, this is at most 8, so this is from 1 and 2. This is from 7 and 8. And this could be any of those digits between 3 or 7 and 7, except for this 5. Right? And I'm also saying that 1 and 2 must be as a pair here, so that this here is at least 3, so that this is at least 7, so this is from 7 and 8, and this is from 3, 4, 5. There is a 3 together with 4 or 5. Yes, that is correct. And this digit now can only be a 6. It's not between 1 and 5. It's not 7, 8, or 9. That has to be a 6. And those are from 7, 8, 9. And on this row, those are from 3, 4, 5. Those two digits sum to 8, so this is 4 or 5. Well, by the way, 8 is no more in those cells, so those are 8 and 9. That's not a 9. And interestingly, in this column, we need 6 and 7 here. Which means that on this row, that's the 5, that's the 4, that's the 3. This is 5, this is not 5, this is 5. 5 plus 3, this is 8, this is 7, so now this is 6. 7 and a 6, this is 1, this is 2. And now 7 hides the 6. So the digits that will be seen are this one, this is 1, 2. And we must reach at least 4, so that this is 8, this is 9. And we see 4 buildings, so that this is 4, this is 4. This is 3. And this is 3. And here we need 3, 4, 8. 8 here wouldn't work because that would have to be a 9. And I think that this is it for this part. We can see that 1 is not in here. And by Sudoku, on this row, 1 can only be here. Let's get back to this arrow. Now, knowing that we have 1 and 3 here, here we have at least 2 and 4, which is already 6. Double 1 here doesn't work, so we need to have at least 1 and 2, which is already 9, so that has to be a 9, and 9 here forces this to be a 2, so that this is 1, and that's a 9, and by the way, 4 and 2 are placed in this order, and it resolves all of that. Okay, so the skyscrapers part has been fully done, so now we're left with, by the way, that's a 7, that's a 9. We're left with classic Sudoku and those 2 arrows. Here we need 6, 8, and 9. That's not a 6, that's not a 9. 6 or 8. So the possible values here are 2 is not available, so 6 can only be achieved with a 3, and 8 requires a 4 or a 5. 5 and 6 are not available for this cell, so this is 7 or 8, and actually, by the rules of Sudoku, this is 8. Here we need 5, 6, and 7. 6 is not available here, 5 is not available there. 1 and 1, that's a 1 in this column, with the 2, that's a 2. This is from 6 and 7. This column needs a 3. 3 is here, this is from 5, 6, 7. What are the options for 8 here? 1 is not available. 2 plus 6 is not possible, so it will have to be 3 plus 5. That's not a 3. On this row, 2 can only go there. Either way, in this box, 5 is here, so that's not a 5. Here I need 2, 4, and 5. So that's the 4. No, I said 2, 4, 5. That's 4, 5, 8 actually. So 4 is correct. This is 8. This is 5. Here I need 6, 7, and 9. 9 goes there. That's a 6. That's a 7. 6, I said. 6 here. This 9 turns this into a 4. That's a 9. 2, 5, 7 on this row. So that's the 5. By the way, this is 8. And 8 here can only be 4 plus 4. That's a 3. This is 8. That's 9. That's 6. This is 7. This is 6. 7 here, 4 and 8. This column still needs a 3. That's a 2. This is 7. This is 5. And this is 7. And no fireworks because I'm using the interface from Sudoku Mahabharat. So the beginning was definitely very tricky, and you can see from the fluency of myself that I did solve it prior to this video. I prepared for this video, but this is more or less the path that I found when I did it yesterday. So that's really a remarkable construction. You can see that the solving path was definitely built in a fashion that's pretty close to what I just showed you. So thanks Harsh for this very nice puzzle, and thanks Tyler for the request, because I'm glad to present this as I didn't present it after the contest itself. And thanks for watching this video. See you soon on SudoKanard.